Okay, so let's work on simplifying rational functions by multiplying. So we just did an example using this. Oh, I forgot to write the other half of it in. Oh, that's okay. So we're going to multiply the first rational function by the second one, which is y plus y squared over x plus x cubed, I think. X plus x cubed. And in the first example that we had done, we common factored out our variable x, y, and then y and x. And then we were able to simplify by factoring. We're going to try doing a bit of a different method. We talked about how this is essentially fractions, and if you call, that first term a, second one b times a times b, or a over b times c over d, you essentially get ac over bd. Well, that means we'd multiply this top by this top, which is a binomial. So we'd have to use our FOIL or your rainbow method or whatever you call it, but it's essentially a distributive property with two terms. We're going to try that and see if we can factor down and get the same answer we had got before. So we'll focus on the top two to start, and then we'll do the bottom two. So we have x times y, which essentially just simplifies into xy. And then we have, so I'll underline each time I do it, green. Then we have x times y squared, which is still positive. We have x times y squared. Again, just kind of push together. Then we have x squared times y, and it's negative x squared, so we're going to say minus x squared times y. And finally, we have x squared times y squared, and it's a negative x squared. So we have negative x squared times positive y squared. And the reason it's negative is to think of the concept of a negative times a positive. Well, then we get a negative value, okay? So there's our top part. We've expanded, and we can possibly simplify. We'll have to see if there's any like terms. We'll do the same thing with the bottom. I just won't use the colors. We'll go through it a little quicker this time. So y times x, same idea. We have, and I'm always going to write the x first, just so for simplicity's sake. And it's common to write alphabetical order with variables, just so when I'm looking above and below, it's a little simpler to try to find like terms. So we have x and y, and then we have y times x cubed, so positive y, oopsie, positive y times x cubed. Then we have negative x times y cubed, and negative x cubed y cubed. Okay. This example is pretty difficult to work with. What you'll notice is none of these are quite like terms. These two look similar, but in the first one, the x is to the power of 1 and the y2, and then it's x2, y1. So they're not actually like terms, so I can't do anything to simplify them. Same with these two here, and then obviously the 2 cubes and the 2 to the power of 1 can't simplify. So I can't do anything to simplify these. I'm going to have to do a little bit of factoring. Okay. What we can look at is that there's an x and a y in every single one of these terms, and the lowest one being our x1 and our y1. So we can probably common factor out. I'm already looking at this. I think it's going to be rather difficult to get to where we were doing this way, because we might have to know a special type of factoring. We'll take it to where we can, and again, not technically wrong, just let's see how far we can get during using this method. So we can take x and y out of everything. It's a common factor in all of these terms. X and y. And the same on the bottom. So we'll have x, y, then bracket. This becomes 1 times 1, so it's the equivalent of 1. Does that idea make sense? Okay, so we have 1. The x and the x is 1, but the y squared divided by y is just the value of y. Okay? Do you think you can help me by going through these? What will this one become when we divide it?
X plus 1.
And actually, it's technically times, so we don't really have to use the times, right?
Yeah.
And it'll be negative. I mean, negative x. And then finally, what about this one?
It would be minus x y.
Yeah, that's right. Good. And then on the bottom, let's see what we get. Same idea. Let's say we factor out x, y, and everything. So we have x, y, and then on the bottom, what will we get here?
1.
Yep. Plus
X squared.
Yep. That's a 3 there in case you can't see it.
Oh, minus 1 plus, or just y. squared.
Yep, that's right.
And minus x squared plus y squared.
Wouldn't be plus, it's still technically times,
yeah.
so y squared. Okay, so again, a common factoring thing. We can cancel out our xy's here. They're the equivalent of 1. So, okay, so we're going to take these two values, the top, the numerator, and the denominator, and we're going to kind of rearrange them. And the reason I want to rearrange them is because I want to do some common factoring again. I'm going to take my positive term, the second term in both, and I'm going to move it beside the last term, just because I want to be able to common factor out a y on top and the x squared on the bottom. I could have factored out the x and the y here, but they have negatives, and I don't want to factor out negatives. I want my first term to be positive. So using that idea, and I don't need really the brackets here, so I shouldn't write them in. Let's write out, this would become just 1 minus x plus y minus xy divided by 1 minus y squared plus x squared minus x squared y squared. Okay, and there's a reason I've done this, and you'll see it as soon as we do it here. The last two terms, I want you to almost think of this like almost like a small separation. I use like dotted brackets. I'm going to common factor out y, okay? And then same concept. It's like a dotted bracket. If you do remember decomposition for factoring, did you learn how to do it? This is similar to that idea where you'd have those two sets of terms and you common factor out of both.
Yeah.
We're going to common factor x squared out of these two. So our next line reads, the first two terms, nothing's changed. 1 minus x, and it's technically a positive y, we factor it out. And then in our bracket, well, what is left? This term becomes 1, and this becomes minus x. On the bottom, similar, 1 minus y squared. We factored out positive x squared, so positive x squared. And then in the brackets, what's left? Well, we have 1 minus y squared. Now, this is the tricky part. You can think of this, and this is a little harder, this as being another term here in front. Okay? And if that's the case, I could technically have a 1 in front of them. Think of it like I've distributed a 1. Okay? And the reason I've done this is because I want you to see that this term and this term are now the same. This term and this term are now the same. So what I'm going to do to help us take a look at this, I'll do it just with the top and I'll try to do it the quick way on the bottom, is I'm going to say let a equal 1 minus x. Okay. So what I'm going to do is I'm going to replace those two top terms. So now this is technically the value of 1. I don't have to write it. I could just write it as a, but the 1's going to become important. So I want to show you that value. 1a plus y a. Okay, the bottom I'm not going to do anything because I'm going to kind of do it the fast way after. I'm just focusing on the top right now. And we have 1 minus y squared plus x squared 1 minus y squared. Okay, well, I could technically kind of combine these two terms here. They both have an a. If this had been a y, it would be like 2y. What we're going to find out here is I can combine these to look like this, and I'll see if this idea makes sense to you. If not, I'll go a little more in depth. But I can write this as 1 plus y times, I should probably stop using so many different colors here, times the value of a. Almost think of it, actually, you know what, completely think of it as I'm going to factor out, or common factor out, my a term. Okay, and normally you write the a at the front, I just wrote it at the back here. So if we were to common factor out that a, you'd be left with a at the front, and you'd have 1 plus y as your two terms after that. Does that idea make sense? Okay, so I'm going to factor out the a on top. I'll keep writing it, I'll write the a in green and the rest in black. So we have a outside the brackets, and in the brackets we still have the 1 plus y. Okay, and on the bottom, and this is where, if you get good at it, you don't always have to do those let statements. I can technically common factor out 1 minus y squared because they're both the same. It's the same concept as turning it into a or calling this b and factoring out the b. It's just that instead of doing that let thing, which is very beneficial, it's a lot of times easier to see. If you can do it this way, it's just kind of quicker. So if I common factor that out, I'm left with 1 minus y squared. And then on the bottom, whatever's left over, well, I have 1 plus x squared. The only problem with the a isn't originally what it is. A is this. So I now have to plug that value back in for a. So 1 minus x in for a. And now if we look at it, 1 minus x, we just plug that back in for the a value. 1 plus y. And then on the bottom we have 1 minus y squared, 1 plus x squared. And if you recall from our other example, this is very similar to where we were before. This is a difference of squares. I'll quickly build it. The difference of squares, 1 minus x, 1 plus y. Difference of squares, we get 1 plus y, 1 minus y, and we still have that 1 plus x squared. These two create a 1 value or cancel out, and exact same as our other answer, we have 1 minus x on top, and on the bottom, what we're left with is 1 minus y times 1 plus x squared. Okay, and a longer method, probably a little more difficult than the common factoring right off the bat, but doable. You still end up at the exact same answer. The other part of this that we have to talk about are the restrictions. And because of the way we did this, it's really hard to tell what the restrictions would be by expanding it. The easiest way to be able to tell what the restrictions will be is when we've actually gone into this form here, and it's kind of like a factored style form. Okay. Now this factored style form is going to be important, and if we go ahead and look up here, we could kind of even set it up here. We really should just common factor and try to put these in lowest terms right off the bat. We should figure out what these factors are. So I'm going to focus on actually these two terms and just kind of separating them the way you would do it in the other question. I'm going to common factor out y in the first set, so we'd end up with y and, we end up with y and 1 minus y squared. And in the other version here, we end up with x and x plus, 1 plus x squared. I keep writing the x over again. X and 1 plus x squared. Each of these are multiplied by each other, and the idea is that we cannot let them equal 0. So essentially, each of these terms, think of it as being 4 different terms, this being the first, this whole bracket the second, this being the third, and this being the fourth. None of these can be equal to 0. So in the very first one, term 1, y cannot equal 0. That's our first restriction. Our second one being y, or 1 minus y squared cannot equal 0. Our third one, x cannot equal 0. And finally, our fourth one, 1 plus x squared cannot equal 0. Well, two of them are already done for us. Y can't equal 0, x can't equal 0. That's the set. The other two we kind of have to work with a little farther. So the first one, 1 minus y squared, cannot equal 0. When I move 1 to the other side, we end up with negative y squared equals, or cannot equal negative 1. We divide both sides by negative 1, and we get y squared cannot equal 1, and we root both sides. We end up with y cannot equal plus or minus 1. So there's two more. And finally, our x value here, I guess I should number this. This was 1, this was 2, this is our third, this was our fourth, this was our third again, and this is our answer to the third. And then our fourth value, we'll work with that again because there's a little work to it. X squared cannot equal 0. Well, what ends up happening here is when I move the 1 over, I almost ran out of space. Worked out perfect. X squared cannot equal negative 1. Well, I can't square root negative 1. And what that means is there's actually no way I can create a 0 down here, because whatever the value would be in this case here, if it's a negative value, well, a negative squared will become positive, and 1 plus a positive number will always be positive. So we'll always have a value of 1 or above, I guess, in this question. So it'll never actually equal 0. So there's only three numbered restrictions, and them being that y cannot equal negative 1, 0, and 1, and x cannot equal our value of 0 with our restrictions. Okay.